So on a coordinate grid, we're asked to graph triangle ABC, and it gives us the coordinates of point A, B, and C. And I assume without a lot of explanation that that's something that's pretty straightforward for us. So I'm going to go ahead and graph this. So point A was at -3 and -4, so this should be where A is. That's a terrible dot. I was hoping to be something larger. Let's see. Those aren't very good. Okay, let me try that again. -3, -4 is point A. Doop. That's good. Point B is at -1 and then -6. So -1, -6. And on this graph, this is the -1 line. So it's right there. -1, -6. And the last one is C, which is at -5 and way down at -8 right there. So I think I should label those points. So I'll label this one. This was point A. This was point B. And this was C. And let me put their coordinates also. A was at -3, -4. B was at -1, -6. And C was at -5, -8. Okay, so the first thing we're asked is what's the length? It says what is AB, and they write it like this. What is AB? And when we write this right, this is read segment AB, and this is read as the length of that segment. So when you see what is AB and no line over it, what we're talking about is what's the length of segment AB. So if I look at our diagram, AB is right here, and we're being asked what this segment's length is. And if I want to know this segment's length, I can look at this right triangle. And I'm just verifying here, but A had an x value of -3 and it went to -1, so this is a change of 2. And the y values went from -6 to -4, so that's also a change of 2. So if I'm asked what the length of AB is, I would say that the length of segment AB is equal to the square root of 2 squared plus 2 squared. So that's me kind of shorthanding the fact that the hypotenuse squared is the leg squared plus the other leg squared. Both of my legs here are 2. So this is the square root of 4 plus 4, which is 8. So we're looking at the square root of 8 is the length of segment AB. And you can leave that as a decimal approximation if you want. You can. This is 4 times 2, right? And I can rewrite that as the square root of 4 times the square root of 2. So simplified radical form, root 4 is just the number 2, and this is root 2. So you can also write it as 2 root 2. So the length of segment AB is either root 8, or 2 times the square root of 2. All right, so that was our first thing, and I didn't even draw the triangle that we're talking about. We're talking about triangle ABC. So there's the triangle, and we figured out the length of segment AB. So now they're going to ask us to do some transformations with this. The first thing B says is it says reflect triangle ABC across the x-axis to form a new triangle, triangle A prime, B prime, C prime. And it says, oh, that's interesting. And it says, what are the coordinates of B prime, and also describe the function that would change the coordinates of ABC to the coordinates of A prime, B prime, C prime. Okay, so we're here, and let me grab a different color. So now I'm going to mark the prime ones with this orange. So let's do A first. It's still going to be, because we're reflecting across the x-axis, right, this axis, the y coordinates are going to be the same. But when I reflect across x, the x coordinates are going to be the same. The y's are going to become opposite. So Oh, that's interesting. So this one was at -4, so it's going to go to +4. So that's now my new A prime. Maybe I should write that. I'll write A prime. And then B is going to be at -1 and +6. So here's B, and I'll label that B. And then the last one, C, it was at -5, -6, and it's going to go -5 to +6. Oh, no, to 8. Go to 8, +8. -5, +8, right there. And that is C, and these are prime. And one of the things that I noticed is all the x values stay the same, right? So B had an x value of -1, A had an x value of -3, and C had an x value of -5. Now, what happened with the y values is they actually became, you can think about it this way, they're actually the absolute values, right? So they were negative before and they all became positive. So we can say the function, well, I could write this a couple of, well, the problem does ask what's the coordinates of b prime. So b prime is at -1, +6. So I think we can come up here and answer this. So I'll write that b prime, b prime is at still -1 for the x value, but then +6. And if I wanted a function that mapped this, I could do this. I could say, look, the xy's are going to get mapped so that the x's stay the same, but the y's become the opposite of what they were. Now, the way that we had this, they were all negative, and we ended up flipping them up. So that would work as the absolute value. But I think anytime you're doing a reflection across the x-axis, this function works, right? Any xy gets mapped to x stays the same and y becomes the opposite of what it was. All right, the next problem says rotate this triangle that we just ended up with, A prime, B prime, C prime, clockwise about the origin to find A double prime, B double prime, C double prime. Okay, so now the game we're talking about is we're going to, let me erase this, is we're going to take this triangle and we're going to rotate this thing about the origin 90 degrees. And I feel like I've just recently done a problem like this within the last couple days. So I'm intentionally erasing these points because I think they're going to get in my way. And we wrote them down up above. And I'm not going to forget that this is B prime. This is A prime. C prime is going to be fine. So when I've talked about this before, I think I've done this thing where, because we're rotating this 90 degrees about the origin, I look at slope lines that go from the origin to the point that I'm going to rotate. So I could look at this line right here. And I know that when I rotate through 90 degrees, I need to get the slope that's the opposite reciprocal of this and then just mirror that off on this side. So if you look at this, I'm going down 4 and over 3. So I think what I want to do is go up 3 and over 1, 2, 3, 4. Right? So if you look at this, this slope was -4/3, and now I've got a slope of +3/4. This slope, if I draw this up 3 over 4 pattern, right, this identifies the exact location of A prime or A double prime. So I'll use this kind of light blue color. So there's A double prime. I'll do the same thing with B, right? So I'm going to go, so I'm talking about this line right here. And if I look at this one, this is down 1, 2, 3, 4, 5, 6 over 1. So now I'm going to go up 1 and over 1, 2, 3, 4, 5, 6. So this point, I'll mark it with that same blue dot. This point is going to be, oh, that's too aggressive. Let me make that smaller. This point right here, that's going to be the point B double prime. And this was A double prime. The last time I'm going to need to do this is for point C. And if I look at C, I can see the slope, right? What was it? It was down. I have to go down 8, and then I have to go over 5. So what I'm going to do instead is I'm going to go up 8. I'm going to go up. That does not look right. No, no, I'm going to go up 5 and then over 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So that point I'll mark with blue. That is the location of C double prime. So this is, oh, get out, there we go. So this is our new triangle, right? After this second transformation of a rotation across, a rotation rather around the origin. Cool. And it really is helpful to do that with the lines drawn back to the origin. Now, I don't think they asked me for the rule. They do not. But they do say, what are the coordinates of C double prime? Well, C double prime ended up at positive 8, or X was 8, Y was 5. So I could say C double prime is located at 8, comma 5. Nice. Nice. Okay, final problem. We are asked to translate triangle ABC so that all the, ooh, now this is interesting. We're not talking about the one we just did, right? We're not talking about the blue one we just left off with. We're talking about our original triangle. So they're making us go back to that. And it says translate triangle A prime, B prime, C prime so that the xy coordinates are mapped onto x plus 8, y plus 6. Describe the translation as a movement a certain distance along a parallel line to the line of translation. That sounds complicated, but believe me, it is not. That's very straightforward. So let's see if we can do that. So we're going to take and increase our x's by 8 and increases our y's by 6. And I have not used the color red yet, so I'll use a red dot. So we're going to increase our x's by 8. So I'm going to move over, let's see, 1, 2, 3, 4, 5, 6, 7, and 8. And I should be landing at 7, right, because I was starting at -1, and I'll put a little red dot right there. Oh, but I'm not done, because not only do I have to move x up by 8, but y has to increase by 6. So I'm going to go to 1, 2, 3, 4, 5, 6. Oh, great. I'm landing right at here, which is on the x-axis, where x is 7. Same thing for point, that was point, so this here is point, well, I can't call it B prime because I already did that, but this is what I get when I take the green one and move over to the right 8 and up 6. So again with A, to the right 8, so I'm at -3, so I'm going to go to 5. Look at me doing arithmetic. And then I have to go up 6 units. I'm at -4, so I have to go up to 2. 1, 2, 3, 4, 5, 6. So I'm going to go to right here. Okay, that's interesting. And then the last one I'm going to do is I'm going to move my C over 8. I'm at -5, so I'm going to end up at +3. That would mean moving 8. And then I'm at down here at -8, and I'm going to add 6. So that's going to land this at -2. Okay. So this, right, is my new triangle right here, this triangle. And I'll sketch this thing. There we go. Now, the last question it asks is, it says, describe the translation as a movement a certain distance along a line parallel to the translation. So if I want to talk about the lines parallel to the translation, what I'm talking about is if I just, every single one of these points, like these lines are all parallel to their original point. So I can draw these parallel lines like this. So what this question is asking is, what are these parallel lines? And I guarantee you they're all exactly the same length, right? They all are, I'll do it for this point. Let me erase this B down here. They are all over 8 units, so this is going to be 1, 2, 3, 4, 5, 6, 7, 8, and then they're all up 6 units,
right? So what happens is we move to the right 8 and then we moved up 6. So the question's asking what is this distance, right? Because I moved this thing along this direction, right? It got pushed along this direction, that many units. So really, we're just asking what's the distance between B and this new point? What's the distance between the original green point and the other one? And that's just an application of the Pythagorean theorem. So I can say that that distance squared is equal to 6 squared plus 8 squared, which looks like 36 plus 64, which looks like 100. So d squared is 100. That means d is the principal root of that. D is the principal root of not 110, of 100, which equals 10. So that distance is 10. So every single one of these lines, right, it doesn't matter which one it is, they're all 10 units long. This one's 10 units long. This one's 10 units long. They're all 10 units long because they're all over 8 and up 6. That is a messy diagram. And it's funny, I was talking to one of the teachers who teaches math too, and he was complaining that he had a very messy diagram and he was trying to find it. And now that I look at this, this is an awful diagram. This does not look very good at the end. Maybe he was talking a problem very much like this. So that the answer to this one is that distance moved is 10 units. So all those points moved a distance of 10 units, right? They were 10 can I spell units? Units. They were all moved 10 units, which is over 8, up 6. The distance traveled there was 10 units. Okay, so that is question number 61, and it's pretty involved, and I wouldn't say ugly, but I'm not happy with how that diagram looks.